All right, this is going to be a real quick one. So we're talking about electromagnetic induction and Faraday's law. So what is electromagnetic induction? It basically just means that you either create a magnetic field from charges moving, or you create charges moving from a magnetic field. So in this case, back in the day, there's this dude named Faraday and there's this dude named Henry, and they're trying to generate magnetic fields, or sorry, currents from magnetic fields. So what they had here was in the center, this donut-looking thing was just a ring of iron. So it's something that can conduct both electricity and magnetism. And they've got wires wrapped around it. And as we've seen, if you have a wire with current flowing through it, you can generate a magnetic field. So they have this switch over here. When they close it with this power supply, it's going to connect and current's going to flow through the loops. Well, the wire is insulated from this iron donut, but it can still create a magnetic field nearby it. So if we take our hand, do the loop, and we do it up, we should create a magnetic field that will then be aligned inside of this. Well, what they noticed with this over here, a galvanometer, this thing is just checking to see if there's any magnetic field strength. And what happens is when they generate that magnetic field in this, it would then create a current through here that would then activate it, and it would show up as current generated. But it would only do it for the small amount of time when the magnetic field was changing. Once you got a continuous magnetic field, like when you push the switch, this guy would bump a little bit, but then it'd go back to normal. If they pull it off, it would bump a little bit, and then it'd go back to normal. And we'll see why that is in just a second. But make sure that you leave a space in your notes here. We're going to do some demos in class where you guys can see this happen in person. But that's it for EMI and Faraday's Law.